So hello, so welcome to this lecture exam P1. So this is lecture 2. The topic is one variable discrete distribution. So this distribution is just a list of all cases, right? So for example, we have this table. So there's our grade distribution in a class. Like we have 50 students. So how many A, how many B, how many C, so how many A, we have such a table. So we can convert this table to a probability table. So like A, so A over 50, so we can say A over 50% got A, so many percent got B. We just changing to this percentage or probability. So such a table is just a probability distribution. Just a distribution, right? So for this distribution, we prefer numbers to indicate different cases, not this A, B, C, D, not as letters. So for example, we just convert those grade A or grade B to GPA, right? So grade A is GPA is 4. Or grade point is 4, so there's 3, right? So this is we say this is a distribution. Okay. So from this table, from this distribution, we wanted to find average GPA for the class. So we find average. We can calculate this way: just 4 grade 4 0.4. So percentage, how many? So we also can do two ways, like here find all points, so divide by 50. This is average, right? So find the total grade points, then divide by 50. So we find this equal 4 multiplied this percentage, then 3 multiplied this percentage, and 2 multiplied this percentage. So in general, from this distribution, we introduce this notation. We call this an expectation. Okay, so this expectation is those x can take in those values x1, x2, xn. So we just x can take this value xi, multiply the probability, so add them up, add them up. So such number is expectation. So expectation is a really important important notation in probability. So as an application, we can check a game is fair or not fair, right? So this game is fair. Like if you toss a coin, face up you win $1, face down you lose $1. So this is fair. So why this is fair? Because it's balanced, or we can say the expectation is 0, right? So equal 1 times the probability 0.5 plus -1 times 0.5. So we find this expectation is 0. So if expectation is 0, so we say good thing and bad thing balanced. So this is fair. Okay. So for a game, we can check this game is fair or not fair. Suppose like here, the game is, if you get an ace, I let you pick one card. So if you pick an ace, you win $5. Otherwise, you lose $1. So we want to find, so what is the probability you can win or get an ace? So such a probability is totally we have 4 aces among 52, right? Or maybe this is 1 over 13. So here's 1 over 13, and here's 12 over 13, right? So 1 over 13, this is the probability you can win. Then 12 over 13, probably you cannot win. So this game is clear not fair, okay? Because the expectation is not 0, or actually expectation is negative. So negative means even this game is not in favor of you. Okay, so we can have such a problem like we want to check if the game is fair, how much you can win, like, how much you should get when you win. So such a problem is just like find a probability problem, right? So let's say pick two cards from the deck. If you get a pair, you will win. So otherwise, you lose $1. So if the game is fair, so how much like I should give it to you? Like when you win, I give it to you. So when you lose, you give me $1. So how much I should give to you when you win? Okay, so here we need to find the probability for win, means the probability get a pair. So here we just pick two cards. So if we pick many cards, we should use combinatorial coefficient, use those notation. If we just pick two, so we can consider one by one, right? So pick two cards. First card of 52. First card actually doesn't matter. You can pick any card. So 52 or 52. So first card you can pick any card. Okay. So second one. So in order to make a pair, so here only have three choices. So why? Because if first one is ace, second one has to be ace, right? So we have three. So if first one is 10, second one is another 10. So how many 10s in this 51 card? We have 3, right? So this equal 1/17. So we can say like when you win, the probability is 1/17. Okay, so the probability you will lose is 16/17, right? So balanced. So we find this x should be 16. Okay. Okay. So we say many situations are just like as a gambling. We have a good case or bad case. So we want to find expected payment, right? Or annual revenue expected payment, like those things. So let's consider this problem. Okay. Suppose a car insurance company has so many customers. Like this insurance company insured 5,000 cars, and the premium for each car 1 year is $800. Okay, so their income, we can say annual income or group income equal 5 multiply 800, right? Then they need to pay out. Payouts. So how much they should pay out? So we say if they have a car accident, they should pay out. So for car accident, we have like those car accident, major car accident should pay this, and this. Excuse me. So we just listen all cases. They need to pay so much. or they should pay this, right? And they should pay. Okay. So this is the money they should pay, pay this or this. Then we need to find what is the probability that they need to pay those money. So here probability. So pay this. This probability 0.002, right? And pay this 0.1, pay this 0.2. Okay. So we can find expectation. Or we can say average payment for each car pay. That's what we can say the expectation for this payment equal this times this, I think it's 300 plus this 500, then there's 200. So this means 800. Oh, the payout is 1,000. Okay, so we say the net payment, net they should pay out 100, but the income for each car, the premium is only $800. So they should pay $200. So this should be, we put a negative because for company, this means the company should pay out so much, right? So the annual revenue is negative. So this equal like each one they should pay this, and this multiply 5,000. Okay, so for this example, we can say the premium is too low, the company will lose money. So they should change policy, right? So they should set the premium at least be 1,000. Okay. Okay. Okay, so let's check this problem. We want to find, so here find expected payment for hospitalization under the policy. Okay, so let's say, so what is the payment is? Payment is pay $100 per day up to 3 days. So this is just like that. First day, 100, 100, just like that. 100, 100, 100. So first day, second day, third day, then 50, 50, 50. Like that, right? 50, 50, 50. Okay? So the number of days, this number of days is X. So this number of days can be one day, or 2 days, 3 days, 4 days, 5 days. Right? Okay. So let's say the payment. So for 1 day, let's say 1 day is 100. So 2 days should be 200, right? Oh, 2 days 200, 3 days 300. So 4 days is 350, right? 5 days is just 50, 50 is 400. So if they stay in hospital for 5 days, pay 400, right? Okay, So what is the probability? So for 1 day or 2 day, or what is the probability for pay 100, 200? So we say the probability for this k equal 1 is 5/15, right? So and k equal to 4/15, 3/15, and 2/15, so 1/15. So once we have this table, so we can find the expected payment. So just the 100, so pay expected payment equal to 100 multiply 5/15. So since this 15 always the same, so maybe we can calculate this way, right? So 200 multiply 4. So 100 multiply 5 plus 200 multiply 4, like this. Then divided by 15. But anyway, the calculation is easy, right? Okay. So from the distribution, so we can find mean or find expectation, we say. Sorry, mean is another name for this. So this is expectation. So this expectation, we can regard this average, like x can be this number, can be that number. So the average for x is this, so x. So then we can have those things, average for x squared, or average for those things, right? So average for anything. Okay, so we denote this average, x average as mu. And for this, typically for this average, so x minus mu squared average, we call this the variance. Okay, so variance. So we denote the sigma square. So we resolve this and this sigma as a standard deviation. So sigma square, we can use this definition, x minus mu squared average, or we can use this. So this formula use this. We can say this is x squared average minus square of the average of x, average for x. Okay. Okay. So this is for a distribution. So we have expectation and variance. So the distribution is we put all cases together, all probability together. So from the distribution, we can find probability, right? So from probability, put, let's say, put all probability together, we have distribution. And go back from distribution, we can find those probabilities. So like for example, we have, so if we know x, this landing variable has this distribution, so we can easily find those probability. Like x larger than or equal to, so can be like 2, 3, 4, right? So equal 0.25 plus like x equal 2, x equal 3, and x equal 4. Or we also can say this equal 1 minus opposite side, x larger than equal to, opposite side x less than 2. Or also here, just x equal 1, so equal 1 minus. Okay. So this is very easy. Like we, from distribution, we can find probability. Okay. So here we x have only few cases, right? Or we have finite cases. So sometimes we can have infinite cases. So let's say so find the probabilities of we need summation for infinite term. So let's check this problem. Like let's say the number of claim, can be 0, no claim, can be 1, can be 2, right? Can be infinity, right? Okay. So the probability, so we denote the probability as P0, the probability no claim, and P1 and P2. Okay. So we find, so the probabilities have this relationship. Pn plus 1 equal 1 over 5 Pn. Okay. So let's say so. So with this information, we can find all P1, P1, P2, P3, or P0. We can find all the probabilities. So we can find, let's say, we want to find what is the probability. So we can find this probability that a policyholder find more than 1. Okay, so more than 1. So this means we want to find the probability like n larger than 1, right? So larger than 1, so equal n equal 2 or 3 until infinity. So for such a problem, we can consider its opposite side. So equal 1 minus Pn equals 0 and Pn equal 1, right? So we just need to find P0, P1. So what is P0, P1? So those probability just have those relationship. So we know all probability add them up should be 1, right? So we say summation Pk, k equals 0 to infinity equal 1. Okay. Okay. So now let's say, so we just use P0 as a standard. Okay. So P0, so P1, we find P1 equal 1 over 5 P0, right? We just use P0 as a standard. So P1 equal that. So how about P2? P2 equal 1 over 5 P1. So P1 equal 1 over 5 P0. So P2 equal 1 over 5 P0. 1 over 5 square P0. Okay, so we know their relationship. So okay, so we find this summation. So 1 equals summation. So this become a math problem. Pk, k equals 0 to infinity. So we find this Pk actually equal P0 1 over 5 k's power, right? So k equals 0 to infinity. So that's equal P0 summation 1 over 5 k. So what is this number? So 1 plus 1 over 5 plus 1 over 5 square. So here we need this formula. We say 1 plus x square plus, so equals us. So when x less than 1 equals us, right? So we just plug in here. Okay, so that's equal 1. So okay, 1 over 5. So which equal, so let's say equal P0 times, so this summation equal 5 over 4, right? Okay, so we get P0 equal, so P0 equal 4 over 5. Then P1 equal 4 over 5 times 1, 4 over 25. Okay, so now we can find this. So we can get to the solution. We finish the job. Like we can find 1 minus P0 minus P1. Okay, so here this example is quite the same. The number of claims so can be any number. So this number of claims, this n, so can be 0 and no claim, 1 claim or 2 claim until infinity, right? So the probability this n equals this. Okay. Okay, so we know there's a probability like n equals 0 equals 1. Like for example, this n equals 0, no claim, so equal 1 over 2, 1, right? Just put the n equals 0, and so we have all those probability. Okay, so what we want to determine the probability that exact 7 claims will be received during the given 2-week period. So this is about 1 week, right? This is probability about 1 week. So we want to find the probability. We want to find the probabilities that we have 7 claims. So here the keywords we have during 2-week period. So let's see, week 1, week 2. Okay, so suppose week 1 we have N1 claim, week 2 we have N2. So we want to find the probabilities N1 plus N2 equals 7. Like what is such a probability, right? Okay, so for make 7, we can say like a first week 1 0, week 2 7, and then week 1 1, week 2 6. Okay, we have those cases. So let's check this case, and suppose like N1 equal, let's say we put like first N1 equal 1 and N2 equal, let's say 6 for this case. What is this probability? So this probability, we say this week 1, week 2 is independent. So we just check week 1, N1 equal 1, so N2 equals 6. So N1 equal 1 is 1 over 2, 1 plus 1, right? 2. And so N2 equals 6. So here equals 6 plus 1 equal to 7. So this equal 1 over 2, 9. Right? So we find so 1, 2, or 0, 7, or 2, 5, those probability the same. So we just check how many cases. So 0, 7, 1, 6, so until 7, 0. Right? So we have 8 cases. So we find that the P also is equal. We have 8 cases. Okay? And each case 1 over 2, 9. Okay. Okay, so for this problem, this the same thing like number of claim have infinite case like the n can be 1, can be 0, can be 0, can be 1, there's n, can be 0, can be 1, can be 2, can be infinity. So we have this probability n equal n is this. So we want to find the probability at least one claim. Okay, so at least one claim. Given that there have been at most 4 claims. So this given that is a conditional probability. We just check this condition. I'm sorry. So given that means we just conditional probability, we just focus on those things. Let's say the condition is at most 4 claim. So this condition is n at most for n is less than equal 4, right? So these conditions, this n can be 0, 1, 2, 3, 4, right? So this is giving that there have been at most 4 claims. So among the condition, so at least one, this part, right? So this probability equal this. So O is probability here. So n less than 4, or n equal 1, 0, 1, 2, 3, 4. So, and here numerator is at least one claim. So, like just we also can use this, like n equal or larger than 1, or n just equal 1, 2, 3, 4. So once we understand this notation, this problem easy. Let's see. So what is this? So n at least equal 4. So this equal n equals 0. N equals 0 is, let's say, so we just plug in 0. So 1 times 2, right? N equals 0. N equals 1. 1 is 2 times 3, right? So n equal, so here n equals 0. Yeah, we put n. N equals 0, n equal 1, n equal 2. N equal 2 is 3 times 4, and n equal 3, 4 times 5. And last one, n equal 4, so 5 times 6. Okay, so this is n less than 4. Okay, so larger than 1 is just this part, right? So here for such things, addition for this, so we know this just equal, like we have this, right? Plus 1 over 2 minus 1 over 3, like that. Okay, so we say this addition is this summation 1 over 1 minus 1 over 6. Okay, so this equal 5 over 6. So 5 is among the 5 over 6. So what is this part? So larger than 1. So larger than 1 is just 1 over 2 minus 1 over 6, right? So added from 1 over from this or this 1 over 2 times 3, 1 over 3 times 4. So this equal 6 over let's see, 6 over 3, 6 over 2. Yeah. Okay, so find answer. So is 2 over 6 over total is 5 over 6. Okay, so this is equal to 2 over 5. Okay, so this is for one variable discrete situation. Okay, so we can stop here.